Transistor CE characteristics. The common emitter configuration of a bipolar transistor is most commonly used setup for amplifiers and switching circuits due to its ability to provide high voltage and current gain. In this configuration, the emitter is common to both input and output sides. Aim to study the input and output characteristics in a common emitter configuration. Equipments required: trainer kit of 1 number, digital ammeter of 0 to 200 milliamperes 1 number and 0 to 200 microamperes 1 number, one for input and one for output. For input 0 to 200 microamperes, whereas for output 0 to 200 milliamperes. Digital voltmeter of 0 to 20 volts or 0 to 30 volts, one for input and one for output, and connecting wires. Specifications: the transistor, for the transistor of CL100S, the maximum collector current is 0.1 ampere and VCO max is equals to 50. Circuit diagram. Input characteristics. Here this is a circuit diagram for input characteristics of common emitter configuration. Here you can observe the DC to 0 to 30 volts. This 0 to 30 volts is the input voltage VBB and resistance RB is to 20 kilo ohms, and IB is the base current which is equal to 0 to 200 microamperes. VB is the base emitter voltage which is 0 to 20 volts voltmeter. With the help of 0 to 20 volts voltmeter, we are measuring the VBE. This side is called input side, whereas the other side, here VCC and current IC, collector current IC, this side is called output side. Now to find out input characteristics, we will keep the output voltage constant 0. We will make VCE equals to 0, and second time we will make VCE equals to 5 volts. This is output. For output characteristics, we will vary output voltage versus output current. Theory. The basic circuit diagram for studying input and output characteristics are shown in figure 1 and 2. In this, the input is applied between base and emitter, and the output is taken from collector and emitter. Here emitter is common to both input and output, hence the name common emitter configuration. Input characteristics are obtained between the input current and input voltage, taking output voltage as parameter. It is plotted between VBE and IB at constant VCE in CE configuration. Output characteristics are obtained between output voltage and output current by taking input current as parameter. It is plotted between VCE and IC at constant IB in CE configuration. Procedure. Input characteristics. Make the connections as per circuit diagram. Keep output voltage VCE equals to 0 volts by varying VCC. Varying VBB gradually, note down the both current IB and base emitter voltage VBE. Repeat above procedure for step 5 volts. In the trend kit, we need to connect a voltmeter to measure VBE and an ammeter for to measure the current IB for input. Similarly, we need to connect an voltmeter in the output side. This knob is used to regulate the output voltage, whereas in the input side also we have a knob to regulate the input voltage. Connect an voltmeter input side. Trainer board plus positive is connected to voltmeter positive. Negative is connected to voltmeter negative. Connect an ammeter in the input side from the trainer board. From the trainer kit, positive is connected to ammeter positive and negative is connected to ammeter negative. Now connect a voltmeter in the output side. Positive in the trainer kit is connected to the voltmeter positive and negative terminal is connected to voltmeter negative terminal. Close the ammeter or short circuit the output side ammeter with a wire. Connect positive to plus to negative. Switch on the power supply. Keep the output voltage VCE 0. Then increase the VBE step by step from 0.1 volt to 0.8 volt. Now note down the base current IB in microamperes. Now increase the VCE output voltage to the 5 volts. Again, vary the input voltage VBE from 0 to 0.8. And now note down the base current IB in microamperes. Observation table for input characteristics. 0 volts, we are varying the voltage from 0 volts, 0.1 volt, 0.2 volt, 0.3 volt, 0.4 volts, 0.5, 0.6, 0.7, 0.8. Corresponding, you will note down the value of base current IB in microamperes. Again, for by keeping output voltage Vc equals to 5 volts, again we will vary the input voltage VB 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. Corresponding, we will note down the values of base current for different values of VBE. Output characteristics. Make the connections as per circuit diagram. By varying VBB, keep the base current IB equals to 20 microamperes. By varying VCC gradually, note down the readings of collector current IC and collector emitter voltage VCE. Repeat the above procedure. Step 3 for IE equals to 40 microamperes. For output characteristics, now no need of input voltmeter. Now remove the input voltmeter and connect the output ammeter. In the output side, you need to connect a 0 to 200 milliamperes ammeter. Negative is connected to ammeter negative terminal, and plus in the breadboard is connected to ammeter positive. By varying the input base current 20 microamperes, now vary the output voltage and note down the output current IE. Now vary the input output voltage in steps of 1, 2, 3, 4, and so on. Now by varying input current to 40 microamperes, again vary the output voltage and corresponding note down the output current values IE. Now note down the output current values IE. For output characteristics, first of all we will keep the input base current constant IB equals to 20 microamperes. Then output voltage will vary the output voltage corresponding. We will note down the value of output current IC, collector current IC in milliamperes. This is a table for output characteristics. Coming to the calculation, input resistance is change in VBE by change in IB. Now if you observe the table, in the table we will consider for 0.7 volts of VBE, corresponding current is 139 microamperes. For 0.5 volts of VBE, the current is of 35 microamperes. Now from this, change in voltage means 0.7 minus 0.5 is the voltage, change in voltage, by change in current is 139 microamperes minus 35 microamperes. Now we can write which is equals to 0.2 volts by 104 into 10 power minus 6. Now if we find out the value, we can obtain the value of 1923 ohms, or which is equals to 1.9 kilo ohms. This is a input resistance. Coming to output resistance equals to delta VCE, change in VCE by change in IC. This is from output characteristics. From the output characteristics table, you can observe here also we need to consider delta VCE by delta IC, change in voltage by change in current. Now here we can observe for 7 volts of VCE and 6 volts of VCE. For 7 volts the current is 6.5 milliamperes, and for 6 volts the current is 6.4 milliamperes. Therefore 7 minus 6, 7 is the voltage, 7 minus 6 is a change in voltage by change in current. This current is in milliamperes. Now 7 minus 6 divided by 6.5 minus 6.4 into 10 power minus 3. 7 minus 6 is 1. 1 by 0.1 into 10 power minus 3. You can find out the value which is equals to 10,000 ohms, which is equals to 110 kilo ohms. You can observe input resistance is 1.9 kilo ohms, output resistance is 10 kilo ohms. Here transistor is a device which transfers the resistance from low resistance to high resistance, 1.9 kilo ohm resistance to 10 kilo ohm resistance. Coming to the beta is equals to IC by IB. Now this is from output characteristics. Now you can observe, now you can take any one of the value corresponding to the IB 20 microamperes or IB 40 amperes. Now here if we observe almost maximum values are 6.3. That's why we will consider any one of the current. For IB by 40 microamperes, collector current IC I consider is 6.3 milliamperes. IC is 6.3 milliamperes, 6.3 into 10 power minus 3 divided by corresponding base current is 40 into 10 power minus 6. Therefore its value is 0.1575 into 10 cube, which is equals to 157.5. The value of beta equals to 157.5. Coming to the model graph. This is the model graph. Now from the table you need to draw from the input characteristics you need to draw the graph. This is a model graph. Okay. Now if you plot the graph for these input values, okay, we will draw the graph for the input values also. This is the output model graph of the output. Input characteristics of BJT. For the input characteristics of BJT, on x-axis take the voltage VBE. VBE means base emitter voltage. On y-axis take current IB in microamperes, where VBE is in volts. For 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. The voltage maximum value is 0.8 and the value of current is of maximum value is 200 microamperes. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. Will increase up, will place the value up to 200. The voltage VB on x-axis and IB is microamperes in y-axis. Now from the table values, for 0 its value is 0, for 0.1 its value is 0, for 0.2 0, for 0.3 its value is 0.3, for 0.4 its value is 4, for 0.5 its value is 35, for 0.6 its value is 45, for 0.7 its value is 139, for 0.8 its value is 194. Now by connecting all these lines, this is for VCE is equals to 0. For VCE is equals to 5 volts, for 0 its value is 0, for 0.1 its value is 0, for 0.2 its value is 0, for 0.3 its value is 0, for 0.4 its value is 0.3, for 0.5 its value is 3.5, for 0.6 its value is 6.3, for 0.7 its value is 55, for 0.8 its value is 89. By connecting all these points, with free hand, This is for VCE is equals to 5 volts. Coming to the scale, x-axis 2 units is equals to 0.1 volt, y-axis 1 unit is equals to 10 microamperes. This is IB, where this is VBE. This is input characteristics of BJT in CE configuration. Coming to the output character, on x-axis 2 units equals to 1 volt, on y-axis 1 unit is equals to 0.5 milliamperes for 20 microamperes of base current. For 1 the value of current is 3. For 2 the value of current is also 3. For 3 the value of current is 3.1. For 4 the value of current is 3.1. For 5 the value of current is 3.1. For 6 also the value of current is 3.1. For 7 the value of current is 3.1, and for 8 also the value of current is 3.1. By connecting all these points, this is for IB is equals to 20 microamperes. Now for 40 microamperes, for 0 the value of current is 0. For 1 the value of current is 6.3. For 2 the value of current is 6.3. For 3 the value of current is 6.3. For 4 the value of current is 6.3. For 5 the value of current is 5 volts, the value of current is 6.3. First the 6 the value of current is 6.4. For 7 the value of current is 6.5. For 8 the value of current is 6.5. Now by connecting all these points, this is for IB is equals to 40 microamperes. Coming to the scale, x-axis 2 units is equals to 1 volt, which is VCE. Y-axis 1 unit is equals to 0.5 milliamperes. This is IC. This is output characteristics of BJT in CE configuration. Precautions. While doing the experiment, do not exceed the rating of transistor. This may lead to damage the transistor. Connect the voltmeter and ammeter in correct polarities as shown in the circuit diagram. Do not switch on the power supply unless you have checked the circuit connections as per the circuit diagram. Make sure when selecting the emitter, base and collector of the transistor. Result. The input and output characteristics of transistor in common emitter configuration is obtained. Conclusion. The value of input resistance is 1923 ohms. The output resistance is 10,000 ohms, and the value of beta is equals to 157.